actually done all the pieces and parts you need here to solve one of these, and I will tell you, some of your problems in degrees will be special angles. It's just that you're not guaranteed if you're working in degrees, they won't have to come out to special angle values. That's a little bigger numbers. Do you think we can factor it? That is a 12. Could be 6 and 2 or 4 and 3. I mean, we might have to play a little bit here, but I think we can find it. We know the back's 3 and 1, so at least we got that part set. So, best guess, 6 and 2 or 4 and 3? We'll try anything. So you know it's got to be 3 and 1 on the other end. If I do 3 and 1 this way, that's 6 and 6. That's not going to get a 5. And if I go the other way, I'm going to get 18 out here. I don't think that's going to work. So it's got to be 4 and 3, because 6 and 2 are going to crash. Okay, so now thinking, where do I want the 3? I don't think I want the 3 inside, because 9 is what I'll get. Well, actually, I lied and take it back. I do want 9.
He's going to be right next to the 9.
I want 9 and 1. So that would give me a 9 cotangent and a 4 cotangent. And I need it to be a negative 9.
Negative 3.
So negative 3, positive 1. Okay, so that's nothing different than usual. Yeah, we had to work a little harder for it. When I solve it, though, I'm going to get cotangent equals 3/4, and cotangent equals negative 1/3. Okay, now here comes the wrinkle in the situation. How do I figure out where cotangent equals 3/4? 3/4 isn't in the special angle table. This is going to be some angle value. Who knows for sure? So we use our calculators, and you still, however, have to go, what quadrants could I be in? Because your answers, unless you're on a quadrant line, you're going to have 2 answers.
You could be in the first and third.
Yeah, first and third. Now, this is the same thing as when we solved Oscar had a heap of apples problems. How do you get your calculator to find you angles? Yeah, we have to do the inverse. Anytime you want it to reverse and find the opposite variable, you need to do the inverse. And for you all, with these calculators, this is now much easier because these calculators have inverse cotangent on them. In the past, the other calculators only had inverse sine, cosine, and tangent, and we had to switch this to tangent before we could do it. Now, you guys can get by with literally hitting inverse cotangent of 3/4 in your calculator.
You round up to 37, or do we keep it at 36?
This book rounds to 1 decimal, so it'll go some angle point something.
53.1.
Yeah. So this, my different textbooks round off differently, but this one goes to the nearest tenth. So they'll say that's 53.1. Oh, yeah. Ooh, this is something you have to watch. Are you in radians or degrees? Yeah, you need to be in degrees to do this. That would be mission critical. Let me pause while you all check. So, yes, after you plug that in, one of the answers is going to be 53.1. And then this third quadrant angle is, yes, 180 plus 53.1. So that's going to be 333.1? 233.1. I'm off. And, yes, I should be putting degree symbols on those. Okay, hold on a sec. Then, when you do the second one, where cotangent is going to be negative then, if it was positive in first and third, it's negative in second and fourth. Now, here's the wrinkle, and I can't because I'm not doing this in the normal order by splitting the chapter in this way. I haven't taught you how the inverse trig functions work. If you plug in inverse cotangent of negative 1/3, you're going to get 108 point something. Can 108 be a reference angle? No. There's a reason it's doing that. It's actually giving you the answer over here in the second quadrant. I'm going to tell you for confusion until I get to teach you that part of it. just don't put negatives in, just do inverse cotangent of positive 1/3. So, because if it tells you this is 108, you're still going to have to figure out what's the reference angle, so you can go find the other angle in the fourth quadrant. So I would recommend just do inverse cotangent of positive 1/3. Don't put the negatives in, and then it won't confuse you. Until we get to talk inverses, that's not going to make sense to you. So if you do a positive, you should get
71.6.
Thank you. 71.6. That way you'll have the correct reference angle for both places. In which case, that would be 108.4, and that'd be 288.4, and you would have all four lovely answers. So when you're doing inverse trig functions, until I get to teach you inverse trig functions, don't put the negatives in. It'll confuse you. Oh, because cotangent is negative in both the second and the fourth quadrant. So I have to... You're doing all four quadrants of answers. Yeah. Okay. All right, everybody with me that far? Because here we go, it's your favorite thing coming back. Actually, two favorite things are coming back. Okay, yoo-hoo! You don't want to miss this one. This one's got a couple of really good things in it. So, you're looking at it, you're going, the first problem is I have two different trig functions in this problem. Okay, somehow I need to get one of them changed into the other. What's the only identity we know that actually connects sine and cosine in the same identity? Yeah. Good old number 6, the most used of all time. This is the number one most important identity. And so, therefore, I'm going to have to change which one of them. Yeah, I'm going to have to change sine squared into 1 minus cosine squared. That baby is never going to go away. And then, do you like how it's written? Yeah, I don't really like that much. So, and I don't want a negative cosine squared very badly.
Put -1 in front.
Yeah. You can multiply it all by -1, or you can think of it as moving it to the other side. Either way, we're going to change signs and make it become cosine squared minus cosine minus 1. And you're thinking, well, heck, this is easy. It's all ones. I didn't. Sorry, have it. But it's impossible. So the question is, can I factor it? But if I do one with a plus and one with a minus, the middle term will cancel. Yeah, those would be conjugates, so the middle term will cancel, so that doesn't work. And I can't do plus and plus or minus and minus. So yeah, what did you just say back there? Yeah, woo! Don't get this back. So, okay, and of course I know you know the formula, but you have to realize what you're solving for here. This gets a touch trickier. Okay, normally, if your equation is x squared plus 2x minus 5 or whatever, when you all do quadratic formula, you do x equals. But in this case, do I write x equals? Yeah. So you have an entire cosine, so it's cosine equals that whole thing. That's not going to be your answer this time. And so it's going to create several more calculator steps for you. But yes, first of all, we need to do the quadratic formula. So, yeah, it's 1 plus or minus square root of 1 squared is 1. Minus, well, because since that's a minus 1 up there, this negative b will be a plus 1. And then a is 1, and c is negative 1. Because you're using this version where it was all nice and cleaned up. because you're solving for cosine. That's what the formula will solve for. Normally, the formula solves for x, but in our case, I'm not done writing yet, but in our case, instead of x, we have an entire cosine. So cosine equals whatever number we get here. So yes, I would do need a 2 times 1 yet. Okay. Well, this one you actually should be able to punch these numbers in your head. I hope you can all handle 1. So that's really 1 plus or minus square root of 5 over 2 equals cosine. Okay. And here's where it gets a touch tricky. Okay. You have to figure out what actual number that is. This is not going to come out nice. It's going to come out to some decimal. So in your calculator, you are going to have to, you're going to have to actually do, first of all, do that square root. So we're going to have to do the whole quadratic formula thing, which was 1 plus square root of 5 over 2. Okay, you're going to have to find out what number, okay. Okay, I need it to go decimal, so yes, I have to ask it to approximate it for me. So it's about 1.6. Note, it's a positive 1.6. That's important. Leave that there a second. I need to go write that down, though. So it's basically, it's around about a 1.6. Is that an angle? Folks, there's so much conversation, and this is the hard part. Is that an angle? No. No. Okay, can cosine equal 1.6? No. Yeah, that's too big for a sine or a cosine. So that one's not possible. Well, okay, good luck. That one's good. Okay. Okay, thank you. So Shannon just ran the negative version, and she got approximately a negative 0.6. Is that possible? Yes. Okay, that's possible. Okay, you need to know it's negative because that tells you what quadrants you're supposed to be in, which is going to be 2 or 3. Okay, now, I need to know at what angle does cosine equal 0.6. So, in your calculator, I need to rerun that a second. Change that to a minus. Oh, we did do it, rats. Okay. So then, how do you get your calculator to give you the angle? You need to do inverse cosine, so you'll have to do a trig function and choose inverse cosine of what? 0.6 of the positive one, and the negative. So and it actually doesn't matter. Normally you'll probably have the decimal there, but you can do inverse of that negative decimal number, or you could do it of the whole quadratic formula version. Either one will work. So I have to go back up then and get that number. Oh, boogers. Sorry. I had moved my cursor accidentally. Go in there. Now go up. Try again. Okay, it's inside now. But because I have a negative in there, it's going to tell me, okay, I'm obviously in radians, huh? So, sorry. You all are in degrees, but I'm clearly not.
Are we going to be in degrees this whole chapter?
Almost, except for one thing today. I know why this wasn't set, because I'm on the other calculator. Okay. Let me rerun that expression. Try that again so it does it in degrees. Okay. So, why did I get 128? 128 isn't a reference angle again. It's got the doggone negative in it. Okay, so you have a choice. You either have to remember to take the negative out, or you're going to have to calculate it off the 128. Personally, I would rather just, when I pop this in there, I'd really just rather kill the negative and not have to deal with it. Go back. So, for right now, ditch your negatives. So it's really a 51.8 degree reference angle. That's the reference angle. We already said it's negative in second and third, so that's 51.8 in the second and third quadrant. And then you can calculate it from there. 180 minus 51, 130, 128.2, and 180 plus 50 would be 231.8. I just went from 180, I subtracted it, and I added it. just normal. So the number you get out of the quadratic formula is not your answer. That's what cosine equals. That's the value it equals. Then you have to do the inverse to find the angle. That's the kicker. You have to realize what you're finding when you do this. You're finding cosine. But not that hard, because you just got to remember to do it. So that's probably the trickiest thing you have. Okay, one other question I need to ask you. Yeah, I know, and I just have like 2 things to say. So I have 2 minor things. If this problem had been, actually here, I'll just do it on another screen. I'm out of space. If I had done, suppose this problem had been in cosecant, and you had some problem you had to do quadratic formula in cosecant. Okay, can you go ahead and solve it in cosecant? Actually, you guys can. Oh, you're spoiled right there. Think about it. Because your calculators do inverse cosecant, cosecant, we don't have to go through this whole mess. Ah, you are lucky. Okay, if you had an 84, you would have to. If you have an 84, you have to do the quadratic formula out, and then you have to turn it upside down and make it become a sine, because those won't do inverse cosecant. So you have to flip over your quadratic formula in order to do one. But with these calculators, it'll do it all for you. Ha! You lucky devil. Okay, now there's one last one. I know. I'm going to say this a little bit. You have one problem at the end of this assignment to solve by calculator. Means literally find the answer by calculator. How on earth would you do that? Yeah, you're going to do it by graphing. And you actually have 2 ways you can do it. I don't care which way. You can put in each one. You can put the left side in F1. Put the right side in F2. And then find where they intersect. But you would have to do this in radians. You would have to be in radians to do it. So I just want you to realize that that's an option for you.